Welcome. In this video I'm going to show you how you can perform a Pearson Chi-Square Goodness-of-Fit test using R and the stikpetR library. If you don't want to use my library, you can watch this video over here where I don't use any libraries. The version of R that I'm using is 4.3. I'm running R in a JupyterLab notebook, but this code should also work in, for example, RStudio. The packages that are pre-installed with R are usually these. This video will focus on how to simply obtain the output, not so much if you should get this output or how to interpret all of it. The Pearson Chi-Square Goodness-of-Fit test is usually done for observed counts and see if they could be the same in the population for all of each category. You might also be interested in a G-test, for example, which is an alternative, and there are quite a few other alternatives as well. To show you an example, I need some data, so I'm loading in GSS 2012A. That's just some data from the General Social Survey from 2012, slightly adjusted for some examples. I'm only going to be needing a marital status, a nominal field, and I'm going to store that as my field. And just to give you a quick impression, here's the table of that, and that should give you the results right there. So the idea is that these categories and their counts should be the same in the population. Now, my library is unfortunately not available on CRAN. You will need to use DevTools, install GitHub, and then just install the library from my GitHub account. Once you've installed it, you can unload it just as any other library. The function of interest would be TS, which is short for Test Pearson Goodness-of-Fit. It requires the data, of course. If you like, you can also add expected counts, and there's an optional continuity correction, which is either Yates, Pearson, or Williams, or of course none. If you run this, then you will get a data frame with quite some different output. It shows you the sample size, the n, the number of categories, k, the chi-square statistic, the degrees of freedom, the p-value, the significance, and also the minimum expected count, the proportion of cells that had an expected count below 5, and a description of the test that was used. In this case, the p-value is below 0.05, which usually indicates a significant result, and we would therefore say that also in the population, the counts are probably not equal across all categories. The minimum expected counts are sometimes important because sometimes this test is unreliable depending on which criteria you actually want to use for this. You can of course use a Williams correction if you like, and it will simply run the test then with that correction. So as you can see that it doesn't change much, the statistic is almost the same and the p-value is still extremely small. Alright, chi-square test is also available in our stats library, and if you like, these are the references, and the hard way of going over all the formulas, etc. I discuss in a separate video, including those corrections that I mentioned earlier. Alright, I hope this video was helpful, and thank you for watching.